What is going, guys? Welcome back. In this video we'll be talking about work. It's a common Calculus 2 application of integration, and it's also a huge topic in physics. Talk about work done by forces. So the easiest way for me to explain this in this case, it will be just doing a bunch, at least one example today. We'll see. Let's hop right into it. Okay, so our example today is a heavy rope, 50 feet long, weighs 0.5 feet, pounds per feet, over the heavy edge of a building 120 feet high. How much work done is in pulling the rope to the top of the building for the first part of the problem. The second part of the problem is how much work done is done in pulling half of the rope to the top of the building. Okay, well, so the first thing I always do here is I like to make a drawing of what's going on. So for the first part of the problem, we have our building that's 120 feet high. Let this horizontal section. Let me switch my hands. Let me grab my pen. All right. So we're going to say, okay, well, let this part be the ground. Here's the building, and this rope, 50 feet long, is going to be. This rope, 50 feet long, is going to be hanging from a building, and as we pull up here, okay. All right, we exert a force. Okay, so there's a force exerted by the rope, a tension force, and there's a force of gravity. Okay, and you need to really think about it. So you need to think about all the forces involved, and so as the rope is hanging, and we are pulling on the rope, gravity exerting some tension. The gravity is acting on the rope as well, counteracting the tension. And so pretty much we're trying to find the work done by the gravity in this first example. And so what I like to do is I like to write out the given. So we know the weight of the object is 0.5 pounds 4 feet, which we know is the force of gravity. And the length is 50 feet. So both of this comes in handy in a bit. Okay, so then I always write out. So then we write out on the hanging. So on the hanging rope, we have a force of gravity acted on the object, equal to delta x times 0.5 pounds 4 foot. All right, and the reason why is because, well, each segment of the rope. Okay, so if we take a segment. Okay, so say we take this section of the rope. Well, as we're pulling up, each segment travels a section of it travels upwards with a distance of delta x. Okay, and so the force of gravity would be the weight times times delta x, given as 0.5 delta x pounds. All right. And so since we pulled the whole weight of the rope, the total length of the rope, it travels a distance vertically of x. So vertically it would travel x. So it goes up x. And so the distance is equal to x. Okay. Now work done is equal to force times distance, as long as it's horizontal or perfectly vertical, assuming it's perfectly vertical. So we get work is equal to our force, which is 0.5 delta x pounds times x feet, which gives us, this is for one section though. Okay, so for one section of the rope. So now we want to find the distance, not the distance, but the total work done. And to do so, we have to add up everything. So to do so, I write out the summation. I is equal to 0, the summation of n, force times distance. And so, plugging everything else in, so work is equal to the summation of our force times distance when I is equal to 0. We start from 0, going to n, where 0.5 times x times x I star. So this I means pretty much our starting point, and our star means our ending point of the number of sections. All right, and delta x times delta x. Okay, so taking a limit of our summation, that gives us the integral. From it, so we have 50. Our length is 50 feet. So, okay, sorry about that. You guys can't see that. Our length is 50 feet. So, as we're pulling on the rope, we start from 0 before we start pulling on the rope, going up to 50. So when we start here, when we first pick up the rope, there's 50 feet left, and as we pull and pull, we eventually run out of rope. So we integrate from 0 to 50 times our work function, 0.5 x dx, and this delta x changes to dx when we integrate. All right, so pulling out the constants, we get 0.5 times integral of 0 to 50 x dx, giving us 0.5 times x squared over 2, evaluated from 0 to 50. Sorry about that, guys. Where were we? So pretty much we have from 0.5 x squared, 0.5 times x squared over 2, evaluated from 0 to 50, and it's equal to 50 squared over 2 minus 0 over 2 squared. All right, leaving us with 2,500 over 4, leaving us with 625 pounds per foot, which is up here. All right, the second part is a bit more involved. Okay, so we want to cut the rope in half. So there's two forces. All right, so we got the rope in half, so we have to count the work done by work 1 and work 2. All right, because in the first half we have tension and gravity, whereas the second half, if we only consider the second half, we only have gravity. Okay, and so pretty much what we do is we say, okay, well, all right, so the upper half, okay, all right, so we start with the upper half, which is right here. Going back to our drawing. All right, so our upper half is right here. So let this be the upper half. Okay. And so pretty much that upper half is going to be going up with a distance. Oh, sorry about that. No, that's not right. This is the upper half right here. And so pretty much what happens is, okay, it goes up, and like in the last equation, it goes up and it exerts a force of 0.5 delta x and travels a distance of x. All right. So work done. So the work done is 0.5 delta x times x, pounds per foot, or pounds foot. And then we also have the lower half, which is this portion here. Okay. And so pretty much, it travels a distance of 25 feet because it only travels half the distance of the rope so far, because it's only dangling halfway, and we have 0.5 delta x, okay, as the force done. All right, so same case, but it only travels 25 feet. So then we add the total work done. So work 1 plus work 2 is equal to this work and this work done by each section. And so work total is equal to summation of I is equal to 0 going to n, 0.5 x to I star delta x, plus the summation of I0 of n of 12.5 delta x. Yes, and it'll be 12.5 because 25 times 5, 0.5, 25 divided by 2. If you guys are confused there. All right, so taking the limits of this, we get the integral from. So if we take the limits of our summations, our work total is equal to the integral of 0 to 25 is 0.5 x dx plus the integral from 25 to 50, 12.5, 12.5 dx. Integrating this side, we get 0.5 x squared over 2. And evaluated from 0 to 25. And on this side, we get, and on this one, we get 12.5x evaluated from 25 to 50. So then we plug in our values. So it would be 25 squared over 4 minus 0 plus 12.5 times 50 minus 25. Give us 625 plus 12.5 times 25. Give us 468.75 pounds foot. So that's an example of doing work. If you guys want me to do more examples of this, we could definitely do more. I'll see you guys next time. Later.